So the four forces that we just discussed can be brought together in something called the three-dimensional equation of motion. And we do that by using Newton's second law of motion and realizing that the force that we're talking about, force is equal to mass times acceleration, it's not just one single force, but it can be a sum of forces. All the forces that we talked about, the four forces, can be combined. So let's do that. We're going to add, or we're going to use gravity, friction, pressure gradient, and Coriolis, all of those. We're going to stick those into one equation. And this is what the equation looks like after we stick everything in. Sum of the forces. Now, remember that we're looking for the acceleration. What we want to do is we want to figure out why is the wind accelerating, what causes it to accelerate. So if that's the case, we're going to take all the forces and divide the forces by mass. So when we do that, you can see that mass drops out of the Coriolis force, that the pressure gradient force, instead of just volume, now you've got volume divided by mass, which is the inverse of density. Gravity, of course, mass drops out if you divide mass by mass, and then friction, we're just going to assume that friction is per unit mass. So here is our equation. This is the equation of motion, and it gives us the acceleration following a parcel of air. So this is a Lagrangian reference frame. It says it accelerates because of these four forces. There is an imbalance in these four forces, and as a result, you're going to get an acceleration. So what this provides us is a three-dimensional vector of the acceleration. And the vector, it's the velocity v vector that's changing with time. In other words, you're seeing v change or accelerate. So when we break that up, we've got u components, we've got v components, and we got w's. And you guys are probably familiar with the components already of wind. So if we substitute that in for v, that gives us for each direction, each the Cartesian grid or Cartesian coordinate system, you'll have changes or acceleration in u, acceleration in v, and also acceleration in w. So here's our equation, and actually this is something that you probably should remember. You might have to do this on the exam where we talk about forces and the equation of motion, but we can see that accelerations result from an imbalance of these four forces. And those four forces being Coriolis, pressure gradient, gravity, and friction. We're going to move on to the horizontal equation of motion now. And in the horizontal, gravity doesn't act horizontally, it happens vertically. So we can get rid of gravity actually, and that leaves this equation. We're down to three forces now.